Imagine walking into a room and being able to control any smart devices naturally, adjusting lights with a glance and a gesture, looking at your speaker while switching the music and its volume with intuitive hand movements, all without pre-programmed commands. But building such seamless interactions face major challenges. How do we handle uncertain multimodal sensor data? How do we adapt to different contexts? And how do we make real-time decisions for frictionless interactions? We present a novel approach that combines a dynamic Bayesian network with a large language model to enable natural context-aware multimodal interactions in real time. Our framework can process multiple input streams such as gaze and touch-based inputs, handle uncertainties, and adapt to different environments while maintaining fast, fluid interactions. Our framework uses a dynamic Bayesian network to model the user's intention-to-action process. The dynamic Bayesian network structure consists of hidden nodes representing user intentions and actions, and observable nodes for sensor data such as gaze and touch inputs. At every time step, the dynamic Bayesian network receives new observations from sensors and updates its inference of the hidden states. As it gradually collects evidence over time, the model accumulates confidence about the user's interaction intention, eventually reaching the decision threshold. To generalize to various unseen environments, we further integrate a large language model into our framework. When the user first enters a new environment, the large language model is prompted once to act as an interaction designer, from which we elicit contextual knowledge about likely interactions from. This knowledge is encoded into the dynamic Bayesian network as conditional probability distributions. When the user interacts in this environment, the dynamic Bayesian network with the stored conditional probability distributions runs at every frame to collect new evidence and infer the user's interaction intention. This design allows our framework to generalize to various unseen environments through the large language model's world knowledge, while maintaining a small network that can perform fast and computationally inexpensive per-frame inference for fluid on-device interactions. To demonstrate our framework, we implement the system for multimodal interactions with gaze and opportunistic touch-based inputs. We evaluate our implementation with 10 participants in an everyday office environment. The setup includes multiple Internet of Things devices and embedded augmented reality interfaces. Participants control lights, browse photos, adjust the speakers, and more with their improvised gaze and touch inputs. Our system demonstrates robust performance, achieving 83% per-frame accuracy in intention recognition. This accuracy holds even in challenging scenarios where devices overlap and are placed close together, and when faced with varying user interaction preferences and noisy input signals. Our framework demonstrates how combining a dynamic Bayesian network with a large language model can enable natural, context-aware multimodal interactions. The key idea is to model the user's intention-to-interaction process with a dynamic Bayesian network that runs inference per frame, and combine knowledge from a large language model that is prompted per environment for generalizing the dynamic Bayesian network to various unseen environments. Our approach can generalize to various unseen environments, handle uncertainties, make real-time interaction decisions, while maintaining a small, low-latency network that can be run on-device.